Alright, so learning target 7.5 for us here is to use and apply logarithm properties. Alright? So, you guys said that logarithms are really just exponents, okay? When you evaluate a logarithm, you're trying to figure out what exponent the base needs in order to equal the number that's being logarithmed, okay? And so, because logarithms are exponents, they also follow your exponent rules, all right? You learned all of your exponent rules, okay? First of all, back in Algebra 1, but we reviewed them a little bit this year, okay? There's basically three rules that are kind of big, all right? One is called the product rule, okay? One is called the product rule. And the product rule says that if you have a logarithm of a product, okay, if you have a logarithm of a product, so this says log to the base b of m times n, so log to the base b of a product, so multiplication. Okay, if you have multiplication, here's what you can do with it. Before I tell you what it exactly is, let me ask you with exponents, what do you do when we multiply? Like if I had x to the fifth times x to the fourth, you add the exponents, right? Okay? Well, remember, logarithms are really like exponents, okay? So if I ask you to do the logarithm of two things being multiplied together, you can actually just add those two exponents together. You can add log to the base b of m plus log to the base b of n. You can add each one of them individually together. So that is the product rule. And again, how do you remember these properties? Well, just remember, they're exponents, okay? And what do you do when you multiply exponents? You add the exponents together, okay? So maybe if you want to, to remind yourself, if you add x to the third times x to the fourth, your answer is x to the 3 plus 4, right? You add exponents together. So if that helps you by seeing that in exponents, maybe add that to your notes too. Okay? So when you're multiplying, you add the exponents together. So when we have a multiplication of a logarithm, we can just add those two exponents, those two logarithms together. Alright? So there's your product rule. There's your product rule. The next one is the quotient rule. Quotient rule. Quotient is a fancy word for division, right? Okay, quotient is a fancy word for division. Alright, so if I have log to some base of m divided by n, well, think about it. What do you do with exponents when you're dividing?
Subtract.
You subtract, okay? So this, when you see the logarithm of a quotient, you can actually just subtract the two exponents. Alright, any questions on that one? And we got one more, alright, and it's called the power property. What do you do when you have a power raised to another power. You multiply those exponents together. Well, here's what we have. Log to the base b of m, that's an exponent, right? Logarithms are exponents, so this by itself is an exponent. Well, we have an exponent raised to another exponent. And when you have an exponent raised to another exponent, you multiply those exponents together. So a lot of times what we'll do is we'll just bring this exponent out to the front and multiply. So we'll say n times log to the base b of m. It's better to put it in the front than at the end, because sometimes if you put it at the end, you might think you got to multiply the m and the n together, and that's definitely not the case, okay? Because the logarithm of m, that's a value in itself. That's an exponent in itself, okay? You don't want to multiply the m and the n together and then logarithm it, okay? So a lot of times we just, anytime we have an exponent, we bring that exponent out to the front, okay, to multiply the exponents together. All right? So those are your three big logarithm properties: the product, the quotient, and the power rule, okay? And they just follow your exponent rules, all right? So they should be fairly simple to remember, all right? In fact, I do think there's a question on the test as to, basically I ask you to write down like this rule or something and say, why does that work? Why is that true? Well, how might you answer that if I ask you, why is this true? Why does this rule work?
Because you're raising an exponent to an exponent.
You're raising an exponent to an exponent. Logarithms are exponents, right? Mm-hmm. So therefore they follow all of the exponent rules. Okay, that would be kind of just a very generic answer to why it works, and yeah, great, good job. Okay. All right. So there's your three exponent rules. There's one more property that we'll use, okay? It's called the change of base. And I kind of changed a little bit the book's definition, but let's say we have log to the base b of some number a. You know how a lot of times on your calculators you are not able, some of you are not able to type in the specific type of base right here, okay? So what this change of base formula gives you is gives you a way to actually evaluate something like this on your calculator. Okay? You can actually take the common logarithm of a and divide it by the common logarithm of b. I won't get into the proof of that. You're probably not concerned as much with the proof of that, okay, as to why that works. But I'll give you an example of it here in just a second. Oh, excuse me. Everybody got that down? So, I know you guys are going to know this answer without a calculator. But I'm going to show you how you could use the calculator to figure it out. Log to the base 4 of 16, what's that answer going to be?
4 is the second.
2, right? Okay, 2, because 4 to the second power, 4 to what power equals 16? The answer to this is 2, correct? Okay? But if you weren't quite sure, you could use the change of base formula, okay? Now notice what I wrote here. Okay? Log to the base b of a, you can just take the log of a and divide it by the log of the base, right? Okay? So using that, what could I do to get my answer? In case I really didn't know the answer, I could take the what? Log of 16 divided by the log of 4. Okay, try that. Okay, so make sure you can do it on your calculator. Log of 16, make sure you close your parentheses. Okay, if you don't close your parentheses on there, it won't work. Log of 16 divided by the log of 4. Okay? Are you getting 2?
Yeah.
Okay? So, there's your change of base formula. So what if I ask for the log of base 7 of 81? Okay, is that a nice answer? No, because what's 7 to the first power? 7, not big enough. What's 7 to the second power? 49, still not big enough. What's 7 to the third power? A bigger number than 81, right? So my answer should be between 2 and 3. Well, use your change of base formula. Take the log of the big number divided by the log of the base, and you should get some number between 2 and 3.
2.26.
2.26? Is that the correct rounding, everybody? 2.26. Okay? Because again, you did log of 81 divided by the log of 7. Okay? So there's your change of base formula. That's my time.
Oh, you're at 11 minutes, 12 minutes.
Okay. Alright? So okay on change of base formula? Alright, now I'm going to go and I'm going to do some problems here in the next part using those first 3 properties that we went over. So if you could pause it for a second.